how did you come up with this X39 stem cell activation technology, and how long did it take for you to perfect it?
Yeah, it certainly didn't happen overnight. It was about a 10-year journey. And actually, when I started, I was trying to find a way to activate stem cells with electromagnetism. And I hold about 70 patents in this area today. And so there was quite a bit of technology that came out of this research. We spent just over $4 million over that period of time developing this. But essentially what we learned how to do was create these devices that, with a combination of what's called an electromagnetic field and a longitudinal field, influence the activity of the stem cells in the body and get the stem cells to function as if an injection of stem cells had been given. So we had worked with the National University of Ireland on this, and their research center on the west coast of Ireland is in the top 2% of research centers globally when it comes to stem cells. So we got this research collaboration with NUIG. We got a research grant from the government of Ireland called Scientific Foundation Ireland, and we began doing this research. And we did our basic cell culture studies, we did animal studies, and then human studies. But we found with this technique, I'll give you one example. We took 30 people, and each one of these people, they had diabetic or idiopathic neuropathy, meaning that the nerves in their feet were destroyed and they were developing neuropathic symptoms, they were in pain, and they were at risk for amputation. And we were able to, in a 8-week period of time, regenerate the nerves in their feet and reverse their diabetic neuropathy. And there's no drug or therapy in the world today that will do that, but we figured out how to do it. And that really led to the development of this understanding that we can use energy, and bear in mind, light is high frequency electromagnetic energy. We can use electromagnetic energy to influence the stem cells without having to give a stem cell injection.
I mean, this technology, David, I mean, for all of us, it just seems like so far out, but we cannot believe today, I mean, the science is here. Can you tell us a little bit more? What is behind the science of the X39?
Yeah, that in of itself is so interesting, because our bodies are actually designed to be powered by light. Now, we often think of sunlight as causing our bodies to make vitamin D, and that's absolutely true. But it's only a very, very small part of the picture. About 10 or 15 years ago, it was discovered that when you put specific types of light on the skin, and it could be infrared light, which we can't see, or visible light, that it will cause real chemical changes in the cells. And for those doctors that are out there, or those people that are curious, it causes an increase. Light will cause an increase in an enzyme called cytochrome C oxidase. And what's important about this, and what's so telling that we're beings of light, is that this is a component of what's called the electron transport chain in the cell. And this is how our bodies convert food to energy. So what this literally means is that our bodies can absorb light and respond in such a way to turn that light into additional energy. So with LifeWave technology, what I found that we could do is take a combination of different types of organic materials, process them to form crystals, and have these crystals engineered so they will reflect different wavelengths of light. When you put the patch on, these wavelengths of light stimulate the skin. They'll upregulate the mitochondrial energy production, and they'll also I'm trying not to get overly complicated with this. Basically, the patches will stimulate the skin with light and change the metabolism in such a way so that we can cause the synthesis of specific signaling molecules, peptides, that will cause a desired reaction. So in the case of X39, we use the patch to stimulate the skin with light. This causes an increase in the peptide GHK, and then this regulates stem cell activity in the body.